Welcome to the Regents Physics Current Electricity problem set, problems numbers 23, 24, and 26. Let's jump right in. You have a 6-volt battery and many bulbs that can hold a maximum of 1.5 volts. How could you connect them so that they light but do not have more than 1.5 volts across each bulb? To answer this question, you need to understand the characteristics of series and parallel circuits. And when you think about a parallel circuit, and remember that voltage is what remains constant, if you hook the bulbs up in parallel, that means they each get 6 volts from the battery, and that would not meet the requirements as described in the problem. This, of course, is a dead giveaway that you have to connect the bulbs in series. In a series circuit, the total voltage is the sum of all the voltages across all the resistors. Therefore, connecting 4 1.5 volts in series would give a total of 6 volts. And if you put more than 4 in series, 5 or more, then you know they will absolutely get less than 1.5 volts each. What this also means is they wouldn't burn as bright either if you did that. So the more bulbs you connect in series, the dimmer they will continue to get. All right, next we have problem 24. 2 lamps have different resistances, one larger than the other. If they are connected in parallel, which bulb is brighter? In other words, dissipates more power. If they're connected in series, which bulb is brighter? Dissipates more power. So the first thing you can see here is that any time that you are asked about bulb brightness, what they're really asking you is to compare the power used by each bulb. All right, here's how to do these questions. Let's start with A. If they're connected in parallel, which bulb is brighter? The way you do this is that you consider, for the type of circuit, what is the electrical variable that remains constant? And for a parallel circuit, that would be voltage. You then select the equation off the reference table that has power, resistance, and the electrical variable that remains constant, so in this case, voltage. Well, in A, that would be P equals V squared over R. So both resistors get the same voltage. That's why you select that equation, so that the numerator doesn't count in comparison. The lamp with the smaller resistance will dissipate more power and will be more brighter. You see an inverse relationship between P and R. So the one that's brighter has more power. This would be the one that has the smaller resistance. Back to B. Connected in series, which one's brighter? So remember how to do this. Power, resistance, electrical variable that remains constant in series, which is current. What would be the equation you'd select to analyze? P equals I squared times R. That way you know both resistors have this variable constant, and you're just comparing P and R. So in this case, you have a direct relationship, so one with the greater power is going to be a greater resistance. All right, lastly, 26. We're skipping 25 and doing 25 in class. Why is it dangerous to replace a 15 amp fuse in a circuit with a 30 amp fuse? This used to be common back in the day, and looking at this picture, I don't know if you live in an old home, you may still even have this in your home. It's called a fuse box instead of a circuit breaker. If it's been made up to code, then it'll have circuit breaker. But these just screw in, and all these, you can see these 4 lines up here, one fuse for each one of these lines. And people would run out of the fuse that would be required to safely operate that line, and they'd have a different one laying around, and so they would just plug that in there because it was inconvenient for them to not have the electricity on for that line. The problem is the 30 amp fuse will allow 30 amps of current to flow through that circuit. The reason you have a 15 amp fuse put in there in the first place is because that's the safe level of current that is supposed to be allowed in that circuit. So the 15 amp fuse that was in the circuit was there because 15 amps is the safety level of the current in the circuit. Replacing that fuse with one of 30 amps means that you will allow that safety level to be exceeded and therefore increase the chances of an overloaded circuit in an electrical fire. And of course, the danger in that is that electrical fires take place inside the walls of your home. Very tough to combat and to locate. All right, ask any questions if there's anything here with any of these that you don't understand, and we will complete number 25 together in class tomorrow.